Hi, this video is about factors. Factors are numbers that you can times together to make another number. So all the factors of a particular number, let's say all the factors of 10, are all the numbers that will times together to make 10. So what can I do to make 10? Well, I know that I could have a load of 1s to make 10. This is often the one that people forget, that 1 is a factor. In fact, 1 is a factor of every single whole number. If you think about it, 1 times anything will give you that number. So 1 must be a factor of every number. Look, there we go. 1 is a factor of 10. That's one of the factors, because 1 times 10 is 10. What else is a factor of 10? Well, I know that I could do 2 times something, because 10 is an even number. It's in the 2 times table. Right, so 2 times 5. 2 is a factor of 10. Well, knowing my multiplication, if 2 times 5 is 10, then 5 times 2 must also be 10. So in that case, 5 is a factor. And if I go back to the start, when I was just doing the ones, I said 10 times 1, or 1 times 10 makes 10. Therefore 10 must be a factor of itself. And again, that's one that people forget, that the number itself is one of the factors. So let's recap. These are the factors of 10 because I can multiply them in pairs to make 10. And I can check that I've got them right by ticking them off in pairs. Well, 1 times 10 makes 10, and 2 times 5 makes 10. And if I've written them in order from smallest to biggest, from 1 up to the number itself, when I cross them off like this, it will always be left and right, left and right, left and right until I get into the middle. You'll see when I do another example with the factors of 12. So what are all the numbers that will times together to make 12? Well, do you remember I was saying that 1 is often a number that we forget as being a factor? Well, remember this time then that 1 is a factor of every whole number. So here are 12 ones. 1 is a factor of 12. In that case, 12 must be a factor of itself as well. Do you remember we said that? Okay, so we've got 1 and 12 so far. What else? Well, 12 is in the 2 times table, so 2 must be a factor of 12 as well. And what goes with 2 to make 12? What is the factor pair with 2 to make 12? How many 2's make 12? 6. 2 times 6, or 6 times 2. So therefore 6 is a factor of 12. Okay, I seem to remember that 12 is in the 3 times table. That must mean that 3 is a factor of 12. Altogether there we've got 12. And how many 3's was that? 4 3's. If we've got 4 3's, then we must be able to make 12 using 3 4's. Yeah, we can. 3 4's. So 4 is a factor of 12. And that's where I run out. There are no more factors of 12. Let's check that we've got them in pairs, because they have to come in pairs. So 1 goes with 12, 2 goes with 6, 3 goes with 4. Did you see that? Left, right, left, right, left, right, until I get into the middle. That only works if I've written them in order from 1 up to the number itself. But it's a useful checking mechanism. I've got 2 special examples left to show you. The first one is the factors of 9. What can I times together to make 9? Right, well, please now start to automatically think of 1 as one of the factors. So 1 times 9 makes 9. And I'll write 9 at the end of the list because I know that it's the biggest factor of 9. And if there are 9 ones in 9, then there must be 1 9 in 9. There it is. So 9 is a factor, right? Okay, what else? What else can I times together to make 9? 3. 3 times 3 makes 9. Okay, so 3 is a factor. Now remember I said they come in pairs, but well, this is a little bit strange because 3 times 3 makes 9, so I need 3 lots of 3, but if I reverse that I get 3 times 3 again. So how do I write that? Should I write an extra 3 in the list? Well, no, that wouldn't make sense because 3 is a factor. You don't need to write it twice. It's not like there are 3 and 3 in the list of factors of 9. That doesn't quite make sense. So they come in pairs, but this is slightly different because there's only 3 factors. So I can't really say that they all come in pairs. Maybe there's another way of saying it. Maybe they come in pairs except for squares. 9 is a square number, and there isn't a list of an even number of numbers in this factor list. In other words, they haven't really perfectly come in pairs for this square number. So maybe for other square numbers like 1 or 4 or 16 or 25 or 100 or any of the other square numbers, maybe they won't come in pairs perfectly either. You'll have to investigate. Okay, the last example that I want to check with you is factors of 5. So I start by thinking of what factors will make 5, and the first one I automatically think of is of course 1. 1 is a factor of 5 because I can times 1 by something to make 5. And what goes with 1 to make 5? It's really obvious. It's 5. Okay, what else can I times together to make 5? How about 2? Can I take 2 times something to make 5? No. What about 3? Could I get a no, I can't. So 3 doesn't go into 5. What about 4? No. Okay. Well, I've got 5. What about 6? No, that would be crazy, right? Because 6 is already bigger than 5. So wait, hold on a sec. These are the only 2 factors. 1 and 5 are the only 2 factors of 5? Well, actually, yeah. I've just convinced myself there can't be any others. So, right, that's peculiar. So that it has come in a pair, but there's only 2 factors. If you remember back to factors of 10, there were 4, and back to factors of 12, there were 6 of them, and factors of 9, there were 3 of them. This is the only time I've ever seen it where there's only 2 factors. Right. Well, in that case, we need to have a special number for the number 5. 5 is an example of a prime number because it only has 2 factors. There are lots of other prime numbers. 2 is a prime number because it only has 2 factors. 3 is a prime number because it only has 2 factors. 7 is a prime number because it only has 2 factors. And those factors are always going to be 1 and the number itself. So in this case, 5. In the case of 2, the 2 factors are 1 and 2. In the case of 3, the 2 factors are 1 and 3, and so on. Okay, that's the end of that video on factors. Thanks for watching. Bye.